Another kind of energy that's of interest to us is kinetic energy. Now, kinetic energy means moving energy, or energy of movement. I mean, that's what kinetic means. So if an object is moving, then it's going to have kinetic energy. So it takes, if I have a pen there, it's sitting there, no kinetic energy. If I make it move though, I have to put energy in it, apply a force, work is done, energy goes into the pen. So how much kinetic energy is there in a moving object? Well, EK, we'll use this for kinetic energy. Then there's lots of different symbols. Some people just use K and various other things. But we'll use EK at the moment for being kinetic energy. Is going to equal, there's a few things it's related to. It's related to the mass. So the heavier the object is, the more kinetic energy it's got, just like momentum. It's also related to velocity. The faster it's going, then the more kinetic energy it's got. But it's actually equal to, if you sit down and do the math, it's actually equal to half mv squared. And what this means is the faster you go, as you go faster, you get a lot more energy, or you need a lot more energy. So an object moving twice as fast has got 4 times as much energy from that squared thing. So we're going to have, this is our mass, this is going to be kgs, this is velocity, this is meters per second, and the unit, if you multiply kgs by meters squared per second squared, you get joules. 1 joule equals 1 kg meters squared per second squared. So any object moving has kinetic energy, and that's one of the things you do and try and do. If you're trying to speed up a vehicle, like a dragster for example, we often use that as an example, as that's speeding up, you're taking the energy from the petrol or the nitro, and you turn that energy into kinetic energy. So let's take a couple of examples of kinetic energy. Okay, so a horse, how much does a horse weigh? 800 kg, I don't know if that's a real value, is galloping 12 meters per second. Reasonable fast. How much energy? How much kinetic energy does the horse have? So let's try this. So EK equals half mv squared, which is equal to half 800 kgs times the velocity squared. So velocity is 12 meters per second squared is equal to 0.5 times 800 times 12 squared equals 57,600 joules. Little or a lot? Is that a little or a lot? Hard to tell. Does it seem reasonable? Pause. Yep. Okay, let's try another one. Recently Elon Musk stuck his Tesla sports car into space. And how much energy would his car have? So a Tesla Roadster in orbit has how much energy? Has how much? Well, okay, well what do we know? We draw a picture of a Tesla Roadster. That's planet Earth. Way going around. So what do we know? We know the mass. Well, I don't know how much a Tesla Roadster weighs. Let's say it weighs 1200 kgs. I know the velocity is going to be around 7,900 meters per second. Orbital velocity around Earth, low orbit, 7,905 meters per second. So around 7,900 meters per second. How much energy does that have? EK equals half mass times velocity squared, which is equal to half 1,200 kgs times 7,900 meters per second squared equals 7,900 squared times equals 337.45 joules. 34 gigajoule, 37, which equals 37.45 gigajoules. That a little or a lot? That's actually a lot of energy. That is an awful lot of energy. And this, to put it bluntly, is why it's so hard to put anything in space, because it takes so much energy to get something going that fast. Okay, so we're now going to start. We've looked at potential energy, we've looked at kinetic energy. We'd better start putting the whole lot together, because often we're going to run these with conservation of energy.